Well, good morning, everybody. I am really excited about the topic of this program. The vision for this, I think, is right on time, and it's something we desperately need. This is about us as the U.S. peanut community controlling our own destiny and finding ways to improve for alternative uses in peanuts. So I really do appreciate the topic today. So when we talk about expanding usage, this is a slide that Bob Parker and the National Peanut Board have shown before. Why should we produce peanuts specifically for oil? Well, we produce 5% of the world's peanuts, but only less than 2% of the oil. We are a net importer of peanut oil, but we always have a large carryout. So finding alternative uses will help us within our markets as we move forward. So I'm going to change gears on you a little bit and give you a few examples of some ways that we can start not just increasing oil, but just increasing new markets for peanuts, because it's hard to separate oil from meal, because if you've got oil, you've still got meal. So we got to find uses for both to make the economic component work out. This is the work of Dr. Onda Latumer. She is with our agency, ARS, up in Raleigh, North Carolina. She is a food scientist, and she is doing a lot of work looking at the impact of high oleic peanuts on both meat performance within chickens, but also egg performance as well. And so I'm going to run through these for you. Peanut and poultry both dominate the Southeast United States, and we need to find a way for them to complement each other. We rank number 1 and number 2, Alabama and Georgia, in broiler production nationally, and are also big egg producers, as we all know. But we import peanut meal into this country. I did not know this until I started looking. We also bring corn and soybean meal or soybeans in from the Midwest, a lot of transportation cost. But in 2021, the U.S. imported $354 million of soybean meal, making us now the 25th largest importer in the world. We can supply this market, I believe, if we wanted to. Maybe not all of it, but we can get some of it. When you look at poultry, they use 22 million metric tons of U.S. soybean meal for poultry feed alone, represents 61% of all meal usage. This is USDA data, and yet we still are importing some meal into this country. So Dr. Toomer started working on this, looking at using in-shell high oleic peanuts as a feed ingredient, but also shelled. We'll talk a little bit about this. And to look at the dietary effects of using these high oleic peanuts in the performance of laying hens, and also looking at it just from, like I said, from the egg standpoint, but also from the meat standpoint. So when we look at what she did, she looked at the conventional corn-soy diet, which is a control, and then we looked at an 8% inclusion in that diet of shelled high oleic peanuts, but also looked at a 4% inclusion in the diet of in-shell high oleic peanuts. So remember, the HPON is the shelled high oleic, the WPS is going to be the in-shelled, because there's some benefits, believe it or not, of the shell within the diet from a standpoint of the performance of the birds. So we all know about the benefits of high oleic. High oleic acid, the higher, the better. And then we look at palmitic acid. Lower palmitic acid is good. We're coming back to this, so remember it. And then lower linoleic acid is good. Not just in peanuts, but in everything that we eat. Now, our bodies need all of these acids, but we need them in moderation. But high oleic, the better the high oleic, that's a real positive for us, and it's been a good selling point for us in advertising. So this is looking at the meat side. And as you can see, when Dr. Toomer did her studies, we see if the pointer works, significant reductions in the meat of the birds of palmitic acid when we had the inclusion of high oleic peanuts and the whole end shells. Both of them had a significant reduction in palmitic acid. They also accompanied that with a significant increase in oleic acid, which is good. So not only are we just feeding a different food stock, it is actually improving the meat quality of the birds. And the linoleic acid went from 500 in the controls, both controls, significant reduction down to 200 to 400. So a significant improvement in the linoleic acid composition as well. The body weights were not changed. Now, this is a good thing because we're improving the meat quality, but we're not changing the performance of the birds. And so that was a good finding that we wanted to make sure that we brought forward today. When you look at egg quality, there are no differences in the egg quality when we include high oleic peanuts, shelled or even unshelled, into the performance, into the diet. And that's another good finding. We're not having negative effects on both either meat or eggs. Now, this is the analysis of the eggs. And as you can see, we had significant improvements in stearic acid in the eggs from the shelled high oleic peanuts. Linoleic acid in the eggs was significantly lower in the eggs, which is good. Oleic, we did not see any differences. And the beta carotene was significantly improved in the egg performance as well. So with the high oleic addition of these peanuts, we're not harming the birds as far as performance or egg performance, but we are improving the chemistry of the poultry meat and improving the chemistry of the eggs. So it's a real positive finding here. Now, I did some math off the back of the envelope, so to speak, but feeding these unblanched high oleic peanuts in this diet is a positive. And if we can enter this market at just a 4% inclusion rate, that could increase the demand for United States peanuts by 150,000 farmer stock tons at the 4% inclusion rate and still benefit the egg industry. So this is really big because y'all know the poultry market is huge, but this is another way that we can increase demand through these positive results that Dr. Toomer is seeing. I'm so glad that Nino preceded me on this because I want to talk to you a little bit about some other studies. This is one that Dr. Johnny Kaysen in Texas is doing, working with Chevron in a public-private cooperative way to develop peanuts with higher oil content. And I won't labor on this very much, but you can see what his objectives are to do this. And this is sponsored by the Texas Peanut Board. Bob, I don't know if National Peanut Board supported his work or not, but it's just another way for us to do this. And with Dr. Brown's program now starting to look at, ways that we can do this in the Southeast, I'm really excited about the potential of this, especially when we start these public-private cooperations. Mr. Joe mentioned this. This is a study that was funded by the Southern Peanut Growers, where we wanted to see what the performance was of peanut oil within engine performance. And as you can see, they followed ARA, which is Applied Research Associates in Panama City. They followed strict guidelines from ASTM, which is the American Society for Testing and Materials. They test almost everything. It's a really big organization. And we wanted to see if we could have renewable jet fuels and diesel fuels made from unrefined peanut oil. So we took about 25 gallons of raw, unrefined peanut oil down to their lab to look at commercial aviation fuels, both Jet A1 and Jet A, and also Navy aviation fuel, which is called JP5. We got the full breakdown on all these. But we also wanted to look at marine biodiesel, which is called F76, and commercial biodiesel as well. And the bottom line is down here, the jet and diesel fuel samples that were produced, Jet A, Jet A1, JP5, number 2 diesel, which all of you use, and F76 diesel, which you use, met all ASTM standards and military specifications. So peanut oil is a very good substrate for using in the military and in the commercial airline sector, because they're when you're dealing with the Navy, I think that might be the next slide. When you're dealing with the Navy and the military and even some of the commercial airlines, it's not that they want to start using more biofuels. They have a mandate that by the certain date, they have to meet this mandate. And we need to position ourselves as an industry to help them meet this mandate. And I think we can do that. I also did a test flight with them on some of the fuels that were made, performed very well. So we're positive there. Another quick one I want to talk to you about is the peanut biodiesel work that we did at our lab. This was under the direction of Dr. Wilson Faircloth. I don't know if Wilson's in the room or here this week. But this tractor ran for about a couple of years on a 50-50 blend of peanut biodiesel and regular petroleum diesel. It worked very well. Now, I'm showing y'all these slides to show you the potential of what Dr. Brown just talked about. These are some older varieties, as you can very well see. And you can see that, that we were able, with these varieties, in a low input situation, to get out about 120 gallons per acre of oil. And some varieties performed well, some did not perform well. This is where we looked at the production cost. Those that performed well, we could produce for $1.75 a gallon. And these are traditional varieties in a low input system that did not have good disease resistance. As new varieties come forward with this project, we know that we can, well, I'm putting a little pressure on you, Nino, but we know that Nino is going to deliver some that are going to lower the cost significantly. Now, when we look at some of these top cultivars in another study in 2007, they averaged about 140 gallons per acre at an average cost of $1.59 per gallon to produce. So this is very doable for us. We actually established at our lab a refinery so that we could take these samples, run them through a smaller size expeller, do the conversions to get them ready for diesel engines, and we were able to do that with a refining cost of 96 cents per gallon. So when you take the cost of, or what we produced them for, and then 96 cents per gallon, we're still in a very competitive position with these older varieties that were produced. So I think as we move forward with improved technology, higher yielding, higher oil output varieties, I think we are at a position that we can be very competitive with a lot of, with petroleum. So that's pretty much what I got for this morning. I just wanted to share some of this with you because I am excited about this topic. It's, as I said, it's us controlling our own destiny. Our export markets are stagnant at best, even declining. We're importing peanut oil and such into this country when we could be doing this ourselves and helping the United States peanut industry and producers control their own destiny. Thank you.